Yo, what's up? Ricky Sanders here. If you live for fast cars, greasy hands, and solving problems under the hood, welcome to your new favourite spot. I'm all about real fixes, no BS, and showing you how to keep your ride running like a champ. So go ahead, smash that like button, hit subscribe, and let's make some noise in the garage. Enough talk, let's get wrenching.
System using air cooling. Here, air acts as protection for the operating unit against overheating. Liquid cooling was previously, in the old days, carried out with ordinary water. Technical progress was reflected in the creation of a special substance called antifreeze. Also, to reduce the temperature of the motor is used TOSOL. Functions of cooling systems. It should be noted that maintaining an optimal temperature regime in the car engine requires protection, not only from excessive overheating, but also from freezing. Overcooling of the unit can cause condensation of the fuel-air mixture, caused by the contact of fuel with the cool surface of the cylinders. Getting into the power unit crankcase, it leads to liquefaction of the lubricant, which is reflected in the loss of most of its useful characteristics. The mixing of fuel and oil causes an annoying drop in engine power. Functionally important engine parts wear out faster. Also negative is the thickening of oil in a supercooled unit. Deterioration of the timely supply of lubricant to the cylinders leads to an exorbitant waste of fuel. The functional capacity of the engine is significantly reduced. In addition to fulfilling the main function, cooling systems additionally provide lowering the temperature of the exhaust gases in the recirculation system, ventilation and air conditioning of the vehicle interior. They are also responsible for heating, timely cooling of engine oil, maintaining an optimal temperature balance in turbocharger units, cooling of the working fluid filling the automatic transmission. Purpose and principle of operation of the air cooling system. It is established that an overheating engine causes exorbitant fuel consumption, also wastes a large amount of machine oil. Important for the normal functioning of the car. Parts quickly fail due to rapid wear. In addition, temperature violations can cause the engine to lose power unnecessarily. The air cooling system is used to keep the engine at the optimum temperature. It also controls the heating of the air in the vehicle interior. It monitors the timely cooling of lubricants, reduces the temperature of the working fluid filling the automatic transmission, and sometimes maintains the optimal mode in the throttle unit and intake manifold. The principle of operation of the system is to remove heat by airflow from excessively heated parts of the running engine. Cylinders, blockheads and oil cooler are cooled in this way. The airflow to the engine is forced by aluminum fan blades, protected by a special mesh from unwanted ingress of random objects that can damage the unit. Deflectors evenly distribute the air coming through the cooling fins between all parts of the functioning motor. Guide diffuser equipped with fixed radially arranged blades of variable cross-section around the circumference, which influence the uniform distribution of the airflow. A rotor with 8 special blades arranged radially, aluminum blades forcing the airflow in the desired direction, a casing that prevents heat from entering from the outside. The diffuser blades change the direction of the airflow, and it rushes in the direction opposite to the rotation of the rotor. This helps to increase the atmospheric pressure, causing better cooling of the engine. Advantages and disadvantages of air cooling of the engine separately. It should be noted that sometimes the natural circulation of atmospheric flows is quite enough to ensure a normal temperature regime. The outer surface of the cylinders of mopeds, motorcycles, piston and other simple engines are equipped with special ribs that promote heat transfer to the external environment. The complex design of an automobile engine requires forced cooling. The airflow must be given a certain direction. Fans are used for this purpose. Air-cooled engines have the following advantages: extreme simplicity of design, which greatly simplifies the process of repair or replacement of unusable parts, relatively light weight, thorough reliability, reasonable cost, good characteristics of cold starting of the engine. However, before you choose a car with an air-cooled engine, you should familiarize yourself with the disadvantages of these systems. They are characterized by exorbitant noise, which is created by the working fan, increase in the size of the engine due to the need for additional space to accommodate the blowing device, unevenness of the direction of air flows, which determines the possibility of local overheating, excessive sensitivity to the quality of fuel, lubricants, as well as increased requirements for the condition of spare parts. Nevertheless, air cooling has acquired its niche in the automotive industry. Such motors are equipped with trucks, agricultural machinery, and cars with diesel engines. Common myths about air coolers: truth or fiction? Unfortunately, the shortcomings of the Zaporozhets finally undermined the confidence of domestic motorists in the air cooling system of the engine. It was accused of strong heating, insufficient power, and rapid failure. While the German Beetle, equipped with such a system, is invariably popular with consumers, pleasing the manufacturer with constant increased demand. Relying on the characteristics of the German car, we will examine in detail some rather common legends pursuing air-cooled engines. Assertion 1. Air-cooled loses out to a liquid system due to high heat buildup, far from being an immutable truth. In fact, the temperature characteristics, on the contrary, can be considered an advantage of an air-cooled engine. Of course, the reduced thermal conductivity does not allow the air to extract heat at the same rate as water or antifreeze. However, the temperature difference between the cylinder surface and the external environment is much greater than the difference between the walls and the fluid moving within the system. Therefore, weather conditions have less effect on the thermal regime of the airbox. The possibility of overheating of a liquid-cooled motor in the heat is much higher. Assertion 2. Larger dimensions. It is also highly debatable. When comparing the size of two engines with equal cylinder diameters and the same piston stroke, but equipped with different cooling systems, the advantage is often on the side of the air engine. Despite the rather imposing appearance of the fan with a deflector and rather bulky housings surrounding the cylinders with heads, its parameters are somewhat more compact than those of the liquid unit. In addition, the water occupies much more space due to the additional equipment taken out of the engine. On the body there is a very bulky radiator equipped with a fan. Also, a large number of all kinds of hoses do not add compactness. Assertion 3. Air systems lose to liquid systems in reliability. Not true. Statistical studies claim that in 1 out of 5 cases of engine failure, liquid cooling is to blame. The cause is failure-prone parts such as thermostat, radiator, pump, etc. The simplicity of the design ensures the reliability of the deflector fan, explained by the low probability of breakage. In addition, lower system maintenance costs are considered to be an attractive point in favor of the air handler. Assertion 4. Air cooling is too loud. Unfortunately, is true. The design features of the air system do not provide the effective sound deadening devices that a liquid engine has. In addition, the ribs of the cylinders and heads of the air vent sometimes, on the contrary, amplify the noise produced by the functioning motor. Designers have provided soundproofing of the liquid system, realized thanks to the doubled walls of the cooling jacket, inside which circulates antifreeze or water. Therefore, in this position, the airman really was in a losing position. Assertion 5. Air engines wear out faster is correct with regard to obsolete systems. The fan simply blows air streams onto the cylinder fins, not providing sufficient uniformity of blowing. Modern engines are characterized by rational heat distribution. Claim 6. Insufficient power. Not quite true. The reason for such an accusation is a deterioration in the weight fill of the cylinders with working fluid, causing a brief drop in engine power. This is due to an increase in cylinder and head temperatures with increasing load, leading to unwanted heating of the air within the system. However, at higher RPMs, the difference in fill ratio between air engines and liquid motors becomes less than the 3.5% established by research, practically going to zero. Therefore, it is possible to combat the loss of recoil by increasing the RPM. Air-cooled engine, air-cooled engine, air-cooled engine, air-cooled engine, the driver behind the wheel of his car. In conclusion, air-cooled engines represent a fascinating and efficient solution for managing engine temperatures without the need for complex liquid cooling systems. By utilizing the principles of convection and radiation, these engines effectively dissipate heat through their exposed surfaces, ensuring optimal performance. We explored the main characteristics that define air-cooled engines, such as their lightweight design and simplicity, as well as their various classifications based on application and configuration. Understanding how air-cooled engines work not only highlights their advantages but also their enduring relevance in various industries. Thank you for watching, and we hope you gained valuable insights into the world of air-cooled engines.